Hey everyone, this is lesson 1-5 and I'm sorry we were not able to get to this in class today, but I am going to do my best to move through it quickly on the whiteboard and in the book. So y'all bear with me and we will try to make as quick of progress as possible. So the first thing we're going to look at is perimeter and area. This is lesson 1-5 using geometry formulas. So we're going to start with perimeter and area of a rectangular figure. We talked in class about how perimeter is the distance around and area is measuring what's on the inside. When we do that, we can do it with square units. So we break our figure up into those units. It could be squares that are centimeters on every side, inches on every side, or an unknown measurement, and we call it square units. So let's start by looking at perimeter. We want to measure how wide and how long this figure is. If we have our length down here and our width up the side, what is our width? It's 2 units. So we have a width of 2, which is going to be true on both sides. And what is our length? Our length is 5 units. This is the one that we did in class. I'm going to turn that L into a 5, and we have a 5 on top and on bottom. And to find perimeter, which is simply the distance around, just like you would find the perimeter of your yard and put a fence around the yard, we're finding the perimeter of the box. So we're simply going to take the measurements and add them up. 5 plus 2 plus 5 plus 2, or 10 plus 4. So let me use that to show you what our formula is for finding perimeter. We use 2 of the lengths, because as you can see, we have 2 of the lengths, plus 2 of the widths, because as you can see, we have 2 of the widths. Another way to write this formula would be 2 outside of parentheses and length plus width. This would distribute to create the same formula below it. This cursive L is the same as the capital L that I'm using. Both stand for length. Okay, so that's how we find perimeter, 2 lengths plus 2 widths, or adding up all the way around. For area, we're going to say length times width. Let's go back to our top box. We're going to say our length of 5 times our width of 2, and 5 times 2 is 10 units squared. If we count the units, we see that there are 10 of them. And remember, we said it's units times units. 5 units times 2 units is units times units, so it's units squared. So hopefully that gives you a good understanding of that one. Let's look at the one below it. This is the one that we derived our formula from. If we have length down here and length up here, width over there and width over here, we have 2 lengths plus 2 widths for our perimeter, and for our area, we simply have length times width. Okay, so that is easy. Let's do a couple of problems for those, or actually maybe only one. Let's find the perimeter and area of a rectangle whose length is 17. So we're going to use the diagram that we already have. Our length is 17. It doesn't need to be labeled on the top and the bottom. We know that it's the same, that they're the same length. So 17 on the bottom, which also stands for the top, and our width, this is example 1, by the way, letter A. So example 1A, our length is 17 centimeters, our width is 5 centimeters. If we know the units, they must be labeled. Remember, if you don't know the units, you can label them as simply units. All right, so let's try our perimeter. We're going to need to add 2 lengths and 2 widths. So 17 plus 17 plus 5 plus 5. So that's going to be 17 plus 17 should be 34, and 5 plus 5 is 10, so 34 plus 10 is 44. So our perimeter equals 2 length plus 2 width. Perimeter equals 44, and we knew that it was centimeters. Remember, it's not going to be centimeters squared because we didn't multiply any centimeters together. So that's our final answer. Let me make sure you're still able to see that. Yes. All right, now let's look at our area. Area of a rectangle equals length times width. So here we have 17 times 5. Area equals 17 times 5, And that, I cannot do in my head very quickly, so that is 85 centimeters. And do you remember what has to come after that when we're doing area? Because we said centimeters times centimeters, we must say centimeters squared. Okay, hopefully that helps you with that part. Let's move on and look at squares. I'm gonna turn the camera a little bit so you can see the square on the board. And I know this is a little tricky because you're also having to deal with reflections. I can see the light reflections as well, so I hope that you can look past that. All right, let's look at a square. By definition, a square has 4 congruent sides. That's why we have 4 tick marks. I'm going to move this closer for just a minute so that you can glance at it up close. 4 tick marks, and the S is side. We don't know the side length yet, so we're just going to call it S. So our formula for finding, bear with me while I get you settled again. Our formula for finding the perimeter of this square is 4 sides. Side plus side plus side plus side, or 4 times whatever the side is. The perimeter for finding the area is side times side, just like we did on the rectangle, or we call it side squared. Side squared would be the same as side times side, of course. All right, so the area for the square formula is side squared. So now let's try that with a number in place. Let me see if they gave us a problem. They didn't, so I'll just make one up. So let's have a side length of 4 feet. Whenever you have 1 mark, that's feet. Whenever you have 2 marks, that's inches. We're gonna just stick to the 1, it's gonna be feet. So perimeter equals 4 side. 4 times our side of 4 is going to equal 16. And again, we must label it at 16 feet. 4, 8, 12, 16. All right, now let's look at our area. Area equals side squared. So in this case, it's going to be 4 squared, or 4 times 4. So our area is going to equal 16. And this time, we have to do feet squared. All right, so just as a quick reminder, to show you that area is counting all the unit boxes inside of it, or how much fills it up. Let's try that. A side of 4, 1, 2, 3, 4, times another side of 4, 1, 2, 3, 4, 4 times 4 is 16. Or let's count by 4s, 4, 8, 12, 16. That's how we calculate our area. All right, the next thing we need to look at is the triangle. I'm probably gonna need to move you again to be able to see the triangle section. Okay. So when we have a triangle, we have a formula that may be a little more foreign to you. Not the perimeter formula, that's simply still adding up the outsides of this triangle, A plus B plus C, simple enough. But when we move on to the area of the triangle, the area formula is 1/2 the base times the height, or base times height divided by 2. These two are exactly the same, just written differently. Base times height divided by 2, or base times height times 1/2, which is also divided by 2. Let me show you why we use that formula. If you look at this triangle, this is an easy triangle to show you an illustration. A triangle is always half of a bigger quadrilateral. It's always a 3-sided figure that you can extend to make a 4-sided figure, such that you can take half of the 4-sided figure and find the area. So let's say we knew the area of this whole square. Let's say one side was 2 and the other side was 2 because it is a square. Then the area of this whole square would be 2 times 2 is 4. So let's write it this way. The area of the square equals 4, and we'll call these inches squared. But the area of the triangle, notice what I've diagrammed around the area to differentiate. The area of the triangle is base times height divided by 2. So this time we know that the base is 2. We know that the height is 2. 2 times 2 is 4, but that gave us the area of the square. So now we have to divide it by 2. 2. Let me erase that because that is no longer legible. 2 times 2 is 4 divided by 2 equals 2. So the area of this triangle that I'm shading in for you is 2 inches squared. I still multiplied inches times inches, so it's still inches squared, but as you can see, the area of the triangle that's drawn in the square came out to be half of it. Now this one doesn't look quite as simple to draw a four-sided figure around, but we actually can, especially if we do some rearranging. We can take apart a triangle and move part of it to the other side, reconfigure a little bit, and then we're able to draw that four-sided figure. We kept the area of our triangle the same, then we have a four-sided figure around it, and if we did all the math, all the formulas on both figures, we would find that the triangle was in fact always half of the four-sided figure around it, the square or the rectangle or whatever we needed to draw, the parallelogram. Okay, so let's go back to just reviewing the formula now that you have a little bit more understanding of why it works the way that it does. Let's put some numbers on this. Let's say the base is 3, the height is 2. Let's get these numbers, 1 and, I'm sorry, 4 and 1. Let's do that. No, let's do it a little bit different. Sorry, I need better numbers. 6, 4. Making up problems is not my gift. Okay, there we go. This one ought to work well. Okay, the first thing that you need to know when you are looking for the area of a triangle is that the base and the height always have to be perpendicular. That's why you see the right angle sign right here. So the base and the height always, always, always have to be perpendicular. You have to remember that. If you multiply this 3 times that 4 and divide it by 2, your answer is going to be incorrect because the 4 is not perpendicular or not making a right angle with the base. So you must multiply the 3 times the height, the perpendicular height, which is 2. So let's use our formula. Area equals base times height divided by 2. Area equals 3 times 2, base times height, divided by 2. Area equals, that's 6 on top and 2 on the bottom, so 6 divided by 2 is 3. And that is, let's say these are inches, we'll say inches squared. All right, so I said my base times my height divided by 2. Now if I wanted to find the perimeter, it would simply be the distance around 6 plus 4, which is 10, plus 3, which is 13, and that's 13 inches. All right, let's look at something in your book really quickly. I was going to see if I could flip that in progress, but I don't think that I can. So hopefully you are seeing what I'm seeing. Sorry, this is a little trickier than I thought it would be. So if you are seeing this, you are seeing, oh, never mind. I think that's being a little bold, that I'm trying to show you something that I can't see. So let's look at this. You can have 3 types of triangle heights. You can have one where the actual side of the triangle is the height because it's perpendicular to the base. You can have a different one where the height is inside the triangle because that's what it took to have a height that was perpendicular to the base. And you can also have one that is, let's see, I need to look at that example. This is our base, but we don't have a perpendicular height. So sometimes you have to draw one. Sometimes you have to even do the math to figure out what that perpendicular height is going to be. Those are the 3 options of where your height can be. Your base can be any one of the sides of any of these triangles. It doesn't just have to be the bottom side, but it can only be a height if it's perpendicular to a base, wherever your base is. Okay, so now let's look at a couple more problems. Let me erase what we've done. And unfortunately, this is getting a little longer than I was intending, so I probably need to stop and start again. Let me do that. So be ready for video 2.